Hypervisors allow multiple virtual machines to run on a single physical host and mediate all I/O operations, including read and write requests. A centralized storage array, such as a SAN or NAS, is typically used to provide shared storage for all of the VMs. Nutanix takes a different, much simpler approach. Its converged architecture incorporates local direct attached storage for faster performance and greater flexibility. Each node in a Nutanix cluster includes flash-based storage to deliver massive IOPS for high performance, as well as hard disk drives for low-cost, high-capacity storage. Adhering to the principles of a software-defined solution, Nutanix implements all control logic as a software-based service. A virtual storage controller runs on each node in the cluster, improving scalability and resilience while preventing performance bottlenecks. With storage and control logic now local to the guest VMs, there's no more need for expensive centralized storage or dedicated storage networks. The Nutanix distributed file system aggregates local storage across all nodes, creating a single storage pool that can be partitioned into one or more data stores. These data stores are then presented to the hypervisor using the standard NFS protocol to provide storage for all hosted VMs. Because the hypervisor communicates to the Nutanix software exactly as it would a traditional storage array, there is zero change to the virtual environment. VMs are provisioned and managed as before, but without having to configure LUNs, volumes, or RAID groups. Now let's look at how Nutanix manages a typical write operation. When a guest VM needs to write data, its request is passed to the Nutanix controller, which then executes the write to local flash storage. It's also important to fully protect data so that it is always available, even if a node fails. To ensure the strongest protection, data is replicated synchronously across multiple nodes. For a typical read operation, requests are served by local storage resources. Keeping data local to the VM provides the fastest possible performance. That means for the majority of read requests, data never traverses the network. With many enterprise workloads, the older the data, the less frequently it is requested. When data becomes cold over time, it is migrated from flash memory to more economical hard disk storage. However, if that cold data at any point becomes hot again, meaning it is requested more frequently by a VM, Nutanix automatically promotes the data back into flash for the fastest possible performance. What happens if there is a node failure? Nutanix supports standard high availability capabilities, such as VMware's HA, so a VM will automatically start on another node. If that VM then needs to read or write data, it sends its request to the local Nutanix controller. If the data being read is not local, the controller determines where replica data has been placed and forwards the request to the correct Nutanix controller. The data is then sent back to the local Nutanix controller over a standard Ethernet network. The local Nutanix controller passes the data to the VM through the hypervisor and stores it locally for future access. At the same time, the Nutanix software once again replicates the data throughout the cluster in order to return the full cluster system to a fault-tolerant state. Each Nutanix node runs independently and leverages the Nutanix distributed software architecture to create a completely unified cluster. The Nutanix virtual computing platform integrates as many as 4 independent nodes into a space-efficient 2U appliance. For more overall cluster capacity, nodes can be added seamlessly one at a time with zero downtime. With Nutanix, you can start small and easily expand to achieve truly massive scale. It's perfect for nearly any virtual workload, including virtual desktops and end-user computing deployments, private cloud projects, big data applications, DR initiatives, and more. Nutanix, the virtual computing platform for software-defined data centers.